Hi everyone, welcome back to Physics Pathway. So here I have a very good questions from the topic kinematics, motion in straight line based on graphs. So the question here is, a two-stage missile is fired vertically from rest with the acceleration shown. In 15 seconds, the first stage burns out and the second stage ignites. Plot the VT. So here we need to find the VT and ST graphs which discuss in two-stage motion of the missile for the time interval from 0 to 20 seconds. So we have two stages, and here in this given graph AT graph is given, so we need to convert this AT graph into velocity time graph and displacement time graph. Okay, chalo, we'll start. So first of all, we need to assume that at 0 second the velocity here is v0, at 15 second velocity is v, and at 20 second the velocity here is v dash. Okay. Now from the definition we know that change in velocities is nothing but area under AT graph, or you can say that integration of ADT, that we know. So change in velocity means here what is from the time for the time interval from 0 to 15 seconds. So change in velocity is v minus v0. What is the area of this rectangle from 0 to 15 seconds? Area of this rectangle is 18 into 15. So v0 initial velocity is 0. So v can be written as 18 into 15 is 270 meter per second. Fine. Now we will go for the time interval from 15 to 20 seconds. So from 15 to 20 seconds, what is the velocity? Final velocity is v dash, initial velocity is v, and what is the area? We need to find the area of this rectangle, this pink shaded portion. So what is the area of this rectangle? That is 20 minus 15, 5 into 25. So v dash is equal to 125 plus what is v here, 270, that is 395 meter per second. Very good. So we'll plot a PT graph based on the information we get. So first from here, this is my 15 seconds and this is my 20 seconds, this is 0 second. So from here at 15 seconds, what is the velocity? Velocity here is 270 meter per second, VT graph, and at 20 second velocity here is 395 meter per second. So if you plot a graph, so before that we know that velocity is directly proportional to time, so you will get a straight line from this. Okay, so if you plot, you will get a so this will be my velocity time graph that has been converted from acceleration time graph. Okay. So now we'll do the same for the displacement time graph. So we know that for displacement time graph, suppose at here it is x naught x, and at 20 seconds it is x dash. So for the time interval from 0 to 15 seconds, the change in position can be written as area under VT graph, or we can say that v dt, or area under VT graph. So what is x minus x naught? We need to find the area of this triangle. So how to find the area of this triangle? Half into base is 15. What is height? Height is 270. So if we calculate, we will get x naught, position x naught is 0. So you can say x is equal to 270. We will get 2025 meter. We'll get 2025 meter. So now we'll do the same for the time interval from 15 to 20 seconds. So 15 to 20 seconds, x minus x. So we need to find the area of this whole trapezium. Area of this whole trapezium from 15 to 20 seconds. So area of this whole trapezium, half into sum of its adjacent side, that is 270 plus 395 into the distance between them, that is 5. So if you calculate, you will get here 1662.5 plus what is x here, 2025. So plus 2025, you will get 3687.5. 3687.5 meter. Okay. So now we will do the same for the displacement time graph. Okay. So from here 15 seconds, this is my 20 seconds, 0 second. So from here, what is x here, 2025 and 3687.5. So if you plot this, know that as the x equal to ut plus half of 80 square. So from here we can say that x is directly proportional to square, so we'll get a parabola. So from here 0 to you will get like this. So this will be your not a straight line, it will be a somehow parabola. Okay, so this will be your answer. So from AT graph we convert to VT graph. So from VT graph we convert to XT graph or ST graph. I hope you understand. Thank you.